and I, instead of putting this underneath here, I move this to the right and put it there. And same thing like that. Why? Because I want in every column to have the same variable. X11, X12, X13, X21, X22, X23. There is a column for every Xij. And in every column, there are only two variables. In every column, look. 1 and 1, 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 1 and 1. So if in a quiz, for example, I'm not gonna do it because this is a little bit tricky, but I could. You know, if in a quiz I give you a matter like this, and the question is this a transportation linear programming model? Then you would say yes. But if I had stuck in this here, let's say another one, you know, put here X11 again, one here. And I ask the question, is this a transportation problem? You say no. Why? Because in every column you have to have this structure. In every cell you have to have this. For horizontal sort of equations here for the rows, and for the column you would form diagonal sequence strings of variables. Okay? Here you have horizontal strings, and here you have diagonal and diagonal. Every time that Amaro has that structure, it's a transportation problem. Okay, this is the same one. So now you can count variables. Okay, how many variables do you have in this problem? You have 2 rows and 3 columns. How many? 6. 2 times 3 is 6. Okay, let's count. 1, 2, 3, 4, 5, 6, because there are 6 columns, 1 for every variable. The coefficients of the ones I have written are 1. This is, I put X11 in. I could say 1 times X11, 1 times X12, and so on. All those coefficients are equal to 1. And these are equal to 0. Put those in green. They don't need to write those, but they are equal to 0. And now I'm going to assume that the dual values for the row constraints, the top 2 are row constraints, the bottom 3 are column constraints. You agree with that? Yes or not? You have 2 row constraints and 3 column constraints. So for the row constraints, I'm going to define the dual values R1 and R2. Why? Because I spell row with R. That's why we are thinking. I spell row with R, and I call the dual values R1 and R2. And if you don't mind, what the heck, I'm going to spell column with K. I hope I'm not cramping your style here. We're in the South, we can do it. Okay, so I put K1, K1 for the first column, K2 for the second column, K3 for the third column. That's the notation we are going to use from now on for the row, R for the column K. And that way I can remember, very easy. Okay, let's write down, I'm going to give you 1 minute. Go ahead, take 1 minute. Write the dual formulation for this problem. Let's see how you do it. Go ahead, do it. Dual formulation for this problem. Without looking at my stuff yet. See what you get. I'm gonna grab another Diet Coke while you crank away and finish the thing. Remember, the key is that one row in one problem is a column in the other one. Or one column in one problem is a row in the other one. I'm going to help you with the first constraint that everybody should have written down. Let's see if you agree with me. Let's look at the screen here, please. Okay. Okay, I'm going to get this one. I'm going to multiply R1 times 20, R2 times 10, K1 times 10, K2 times 12, and K3 times 8. That is a minimization problem. This is a maximization. That will be a minimization problem. And that's the objective function of the dual value. I'm sure you have it right. Do you have it right? The objective function of the dual value should be minimized R1, 20 times R1 plus 10 times R2 plus 10 times K1 plus 12 times K2 plus 8 times K3. Okay, raise your hand if you had it right, please. Okay, thank you. Now let's write the first first constraint. Then I'm gonna have this column, the first column. Then is 1 and 1. Look, 1 and 1 becomes, it's actually 1, 0, 1, 0, 0. When you write the first constraint in the 2O, the coefficients are 1, 0, 1, 0, 0, and you put it as a row. Okay, then as a row you will write, as a row you will write 1 times R1 plus 0 times R2, so R2 doesn't show up, plus K1 times 1, plus K times 0, plus K3 times 0. So at the end you have only R1 plus K1. You agree with that? And it's gonna be, okay, this is what I wrote here. Minimize 20 R1 plus 10 R2 plus 10 K1 plus 12 K2 plus 8 K3. And now this one, okay, we have 1, 0, 1, 0, 0, and this is for R1 and this is for K1. And then look at the bottom. This R1 plus K1 larger than or equal to minus 3. Or if you want to, R1 plus K1 plus 3 larger than or equal to 0. That's the way I'm going to write it. So please raise your hand if you follow this. This is important for the development. You can do it. If there is, you have questions, I'll be glad to answer them for you now. Look, if you are thinking about x1, the constraint for x1, then x11 uses R1 and K1. Now let's say that you want the constraint for x21, this one. x21 is R2 plus K1. See, the subscript will tell you already. The first subscript is for the row. The second one is for the column. So this one will be R21 is R2. And then the next one, R21 here is for K1. So it's the row and then column. So R2 plus K1 larger than or equal to, and then you look at the constraint, at the objective function for 2, 1 is minus 6. So I'm going to give you the model there. Look. There you have the dual formulation. And look at the bottom. Since in the primal all the constraints were equalities, then all the R's and the K's are unrestricted. Correct? Right? They are restricted.
So, okay, right here, this
Yeah.
is.
Yeah, that's the one for.
Greater than. So then we know, so this was minus. Hit minus. So that was for maximization.
It's like this, I did this here with this one. Look, this is what I did here. This is a maximization problem, so it's Ri plus Ki, like that equal to -3, it's minus. But then I switch this -3 to the left, and it becomes this.
Why?
Okay. Plus.
Because I want to write those constraints in that way. I want the right-hand side to be 0 all the time. You will see why it's convenient. So if you know how to do the what I did at the bottom, you should be able to get everything else. You agree with that? Yeah, you got everything?
No.
Okay, which one did you get?
No, it's trying to follow that matrix. The matrix makes sense.
Follow the lines here to put the constraint. As an exercise, write the dual value like I did here for x11 for this column. Now do it for the column x21 to see what you get. x21. What did you get? Stacy?
Greater than or equal
To 1.
0 R1
Plus
plus
six.
1 R2 plus 1 K1 plus 0 K2.
For 2-1, right?
Yeah.
So you got R2.
0 K2. I got R2 and K1
Yes.
minus 6 is greater than or equal to 0.
That's correct.
Which one is that? X2.
Los switch, no, switch the -6, you have a -6 here.
The 6x2.
Yeah,
The
so
switch is,
Okay.
so you
Six
can
is
cross,
6, yeah.
the 6 like that. Yes. So for 2-1, check your work, you should get R2 plus K1 plus 6. This 6 is the negative of this. Like that equal to 0. Okay, raise your hand if you got that one. I will give me feedback.
Did you say
Okay.
R2 plus K?
R2 plus K1 plus 6 equals 0. See, I want you to be able to solve this very quickly because that's the key to solving the transportation problem coming up.
Greater than.
It beats the heck out of the simplest method. Once you understand this rule, if you start solving the problem with the transportation simplex, and somebody solves the problem with the simplex method, you do it with the transportation simplex method that we are going to learn today. You finish in half the time. Okay, look. This was the one for R21. Look, R2 plus K1 like they are equal to -6. But I put the 6. I'm going to switch the 6 to the left, and it will be like to 0. And then I increase the 0. And Ri and Kj's are unrestricted. Okay, now this is the general formulation of the dual pattern on top. So it's really the minimization, the sum of the AI's times RI's plus the sum of the BJ's times KJ's. Very simple, easy to remember objective function. So you multiply the availability figures by the dual values of the rows and the demand conditions by the dual values of the column. And every constraint is this, Ri plus Kj plus Cij less than or equal to 0, as you saw before. I don't write the zeros there. Okay, raise your hand, please, if this is clear to you. This is the general formulation. Okay. How about you over there? Guys over there, burn calories. Okay. That is the maximization problem. Look. These are two rows, so these are the row constraints. There are three columns, these are the column constraints. I haven't done anything except that I separated now with the blue lines, I separated the row constraint from the column constraints. And here, let's go into matrix notation. I want to write first the vector of decision variables. The vector of decision variables. Okay, I'm gonna list, I could list them in any order, but we need to follow a systematic order. The order is, we are going to do it in this order, x11, x12, so that's the first row. Then x11, x12, x13, that's the first row. The second row, x21, x22, and x23. So how do you put the variables in the x vector? The answer is you put them according to the rows. First, the ones in the first row, from left to right. Then those in the second row, from left to right. And continue like that until you hit the last row from left to right, and there you have your vector x. Okay? Clear?
Why couldn't you just use the objective function?
Excuse me?
Why couldn't you just use the objective function? 'Cause it's
Well,
the
well,
same
I'm
as
defining
the
x here.
row.
I'm getting it from the objective function. Look, this is x. So I put it here. x11, put it in here. x12, put it there. It's the same thing that you are saying.
Okay.
x13, put it there. x21 there, x22 there, x21 there. But you do it with the objective function if you have written those in the order I said. Because you can write the objective function in any order.
Okay.
So,
Okay.
so this is the order. Okay, this is the vector of objective function coefficients for this variable is -3, look. -3, -4, -7, -6, -3, and -2. Now let's get the vectors of coefficients of the constraints. They are called column 1, A11, A12 for the second column, A13 for the third column, A21 for the next one, A22 and A23. So I'm gonna get those. And notice that every vector has 2 1s and all zeros. 2 1s and the remaining figures all zeros. Now, since everything is 0 except 2 1s, so the important thing is where do we put the 1s? The answer is in here. So if this is for the row, and this is for the column. Okay, let's look at that. Here, this is 1. Oh, sorry. So this is 1, 0, 1, 0, 0. Okay? So the first one is for the row, x11 is in the first row, and x11 is in the first column. First row, first column. So 1, 1, first row, first column. Then you have, okay, for the rows and then for the columns, okay. This is row 1, row 2, and then you start with the columns. I think I have this. That facilitates the thing. Okay, let's do that. First one, first row, first column. Okay, first row, first column. X12, first row, second column. First row, second column. Remember the columns are here. But you need to remember how many rows and how many columns. And then after the rows, follow the columns. Row 1, row 2, and then column 1, column 2, column 3. Let's say 1, 3. 1, 3 is first row, and third column, 1, 2, 3, here is the one. Now, 2, 1. 2, 1 is the second row. Okay, this is the second row. And the first column, this is the one. The other one is second row and second column. So this is the third row, second row, and second column, first and second, so one row. And the other one is second row, third column, second row, third column. This is the way to put those numbers. Actually, maybe I'm making a big deal out of that, but you can get this directly from here. Here, even there, you say, okay, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0. But here, I'm giving you a little insight. It's important. This little insight is important to do things pretty fast. Because if I want to write the dual condition for this one, remember the dual constraint, then I say R1 plus K1 plus 3 here, like that equal to 0. Okay, now for this one, it will be R1 plus K2 plus 4, like that equal to 0. And you continue like that. This one, you say R1 plus K3 plus 7 here, like that equal to 0. Okay, quickly. So that's X, that's C, those are A's. Now comes this thing. How do you get the Z minus C value? Then it will be Zij minus Cj in the maximization problem. Remember, this is for a maximization problem. It will be equal to Y times Aij, Y times Aij minus the Zij, but remember that Zij I have switched here inside because I transformed the original problem into a maximization problem. So it's minus Zij and I get this one. So the Zij minus Cij values are really equal to Y times Aij plus C sub ij. You agree with that? Think about it. I put them out of the coefficient here so you can see that they are switched inside. So when you do this subtraction here, this, then it's minus Cij, but the Cij is really the negative of the original one because I transformed the problem from the minimization to a maximization problem. Okay, now, what is, for example, Z12, okay? This is Zij, okay? So notice Zij is equal to Y times Aij. This is equal to this, and this is equal to this. So let's practice with one example. I want to do it for 1, 2, for this one. Okay. So Z12 is equal to Y. See, the vector of dual values are R1, R2, K1, K2, and K3. You start with rows and then follow with columns. R1, R2, K1, K2, and K3. Then the A for 1, 2 is 1, 0, 0, 1, 0. Okay. That's where it helps to remember that this is for the first row, and then column, the second column, this is first column, this is second column. Now when you multiply this times this, you get Ri plus K, R1 plus K2. So So Z12 is always equal to, you look at the first subscript, 1, then put R1, second one, put K2. So Zij is equal to Ri plus Kj. Z12 is equal to R1 plus K2. Z24, for example, in any problem, it would be R2 plus K4 and so on. So it's always an R plus another K, and the subscript for R and the K are borrowed from the subscript for Z. 1, 2, then the first for R, and the second one for K. Very systematic. And if you subtract now the minus C12, then you get Ri plus K to R1 plus K2 plus C12. It's really the same thing that I did here. For any same thing that I did here. But I'm doing it in a more formal way, using the matrix notation.
And all you're doing with this is still just proving your table.
Yes.
You're not solving for your table, you're just
No,
proving.
I'm not solving anything yet. So let's do it one by one. Look, for 1, is this one, R1 plus K1 plus C12. For 1, 2 is R1 plus K2 plus C12 is this one. For 1, 3, 1 R1 plus K3 plus C13. Now for 2, 1, remember it's 1, 1, 1, 2, 1, 3, first row. Then the second row, 2, 1, then you get R2 plus K1 plus C2. And then 2, 2, second row, 2, 1, 2, 2. And then you get R2 plus K2 plus C2. And for the last one, Z23 minus C23 will be R2 plus K3 plus C23. So the calculations for all for this problem, all the calculations are in here. Okay. Because how many entries do you have? You have 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3. Every entry is a variable, an Xij. Okay. So for X11, you have this. For X12, you have this. X13, this. I finished with the first row. Second row, 2, 1, I have this. 2, 2, I have this. 2, 3, I have this. And for the basic variables, what is the Z, the value on top of the simplex method, for the objective function, when a variable is basic, what number do you have in that row? 0. So we have 0. Because that 0 is the one that contributes to the identity matrix. Remember that. So here I'm borrowing from the simplex method because I'm kind of using the simplex method here. And say, okay, this calculation, these are the values in the objective function. Those are the values that I have in inside this is Cij, this is Xij, and these are the values that I'm going to put here, Ri, Kj, Cij, those values I'm going to put in the quarter circles. This value here. So for every cell, I have this calculation, and these calculations are done here. These are for the cells in the first row, and these are for the cells in the second row. Every one of these is one of these. And when you do that calculation for a basic variable, when you solve this for the simplest method, you will get, see, I'm not doing it yet, but we will get zeros for the basic variables. Now I start with the transportation simplex. This was the kind of the background information that you need.
Can we get a break? 1 minute, a break? Break?
Thank you. I'm just warming up.
No.
Okay, take 5, 10 minutes.
That's what I was
Take 10
afraid of.
minutes.